So hello everybody. Oh, I should angle my um so hello everybody. Can you hear me? Just share in the chat or repeat back if you can. Okay, great. Thanks. So let's get started. I'm sorry for some minor technical delays. Oh, but well, here. Well, let's code Java. This is the first day of this lesson, and hope you can be taught Java. So, to give a quick introduction of what we're going to be doing today, first of all, I will explain to you why should we learn Java. Well, Java, and this is to explain why is Java an important programming language to learn. Second one is an exploration. This is of the setup coding environment and of the experiment with the virtual robot simulator. The third one is that you can then go and use the robot simulator. Right? What? You can't hear you. Wait, can you hear me or Andrew Ang? I hope I'm pronouncing that name correctly. Can you hear me or I hope you can. Oh, okay. Am I somewhat muted or let me take a look at the spear second. I'm sorry. Microphone access. Yes.
Yeah, Eric, I think everybody else can hear you. It's fine. It's probably somebody has the other set. So I think we can continue.
Great then. Great then. And okay, so for part 3, you can then go and use the robot simulator to go and well, see how what you've learned can be applied onto a simulated robot. And for the fourth one, we'll do a small little challenge. Some fun. So, first of all, why should you learn Java? Well, Java is a very versatile computer science language. It's used in data science, machine learning, app development, and web development. Its library is for many different purposes. More importantly, it's used to program robots. The Java language is used in almost every single industry. It's very versatile, and it helps increase your chances of employment significantly. So here's some exploration. So go to the website, HTTPS. Well, you can see the link on the screen. And then hover over the programming and select play. Follow the text guide when prompted to learn how to navigate the virtual robot simulator. And if there's no text to guide you, hit the how to use the button in the upper right corner. When you are done, just so that we're all on the same page, do be sure to send a message in the chat. Nope. So again, just as a reminder, if you have managed to navigate yourself to the website and follow the first 4 instructions, do be sure to go and tell me in the chat. If you have trouble, don't be afraid to go and ask just through voice chat or, yes, it is. We're going to find the programming. Yes. Oh, alrighty. So can you see my screen? This is the Ultimate Goal website. Nicole, you can see this, right? Well, okay. Well, programming is in here. Okay, great. Great then, Eric. So, Nicole, the programming is over here. Just click play, and it'll bring you over to the screen. Then afterwards, you then click this button over here, next to blocks. Okay, and then this is, and then you can go to onBot Java. Great then. Let's see here. Re-navigate to the PowerPoint. Yes. Bowen, if I send you to a different page, could you send a screenshot or something? So I maybe see, or do you want a screen share? I'm okay with either way. Oh, okay, that's good. Well, great then. It seems like the majority of you are getting in already, so I'll move on to the next slide. If any of you if any of you don't want me to move ahead, do be sure to just tell me in the chat, and we can go back to the previous slide. So select the onBot Java and copy and paste the link into your code. Here's the link: https rg. Well, I'll just go and put it in the chat. Yep. So go to that link. It should give you a Google Doc file, and then you can copy and paste it into your project. If you want, allow me to go and give you a slight demonstration. So control. So here it is. This is the day 1 example code. Press Control C. Then afterwards, in the Virtual Studio Code, you just copy and paste it in. So, like before, do tell me when you are done. So we can move on. And again, if you have any problems, don't be afraid to share. Oh, okay. Zifan Xu. I can't get the doc. But let's see if I can copy and paste what the doc says into the chat. UN for the group name chat. Okay, so unfortunately, someone hasn't been able to go and access the code. So I've gotten copy and paste it into the chat, so you can just copy and paste off that. Is it working for you? Okay, great. So it seems like most everybody's done. Now, time for our first little experiment. Try changing the numbers in the front left and front right and set the power statements from 0.1 to 0.5 and observe what happens. Oh, wait a second. I realize I'm probably moving a bit fast. I should probably first show you what the code does, first of all. So you can see my screen. So as you can see on my screen, this is the code on it. First, you want to initialize the program in this upper right-hand corner. As you can see, the objects will jiggle around a bit, showing you've initialized it. Then afterwards, you can start the program and watch what happens in the bottom right-hand corner. Now, I'll let you all try this on yourselves. Tell me when you've managed to go and start running the code. Have you all managed to run the code? Oh, let's see here. Somehow my bot did not move despite following the steps as shown on your screen. Well, all right then. Well, first of all, did you copy and paste the code into the FTC into this on-bot Java? Okay. Next, initialize the program. Cannot paste. Well, I'll go and resend the code over in the group meeting chat. Again, do see if you can paste it from the chat. If you cannot, then I am very sorry. So again, if it doesn't work, then you can always, as suggested by Boland, just reload the tab on bot Java. Copy and paste the code. Initialize the program. And then you can start the program. I'm not sure if that fixed the problem for you. Oh, okay, great. I'll let things. Oh, yes, because oh yes, okay. So it should jiggle. That should be normal when you initialize the program because you were just simply initializing it. Only after you start the program does the robot actually move. It still doesn't move for me. Still doesn't move. So are you like initializing the program and have you started it? Have you both initialized and started the program on your computers, or does it not work even after you do that? Perhaps would you like to oh, I've done it. Oh, okay, great. I tried reloading it, but it doesn't work. It doesn't work, works after reload. It works. Alrighty then. Oh, well, this is loading tools. It works. And steps again. Well, bit concerning. Works for me. Okay. Well, I suppose if you have problems, I can just work with you during a more work during the more free work phase. Okay. So I'm sorry it doesn't work. For the interests of those who have had it to work and don't want it to sit around for forever now, I'll go let them experiment a bit, and then afterwards I can help you more personally. So for the first experiment, try changing the numbers from the front left and front right wheel to dot set power statement from 1.0 to 0.5. Observe what happens. Try changing the sleep values underneath to different values and observe what happens. Oh, great, great. You managed to go and figure out some of the problems. Great then. So this is the experiment. While you're doing it, I want you to think, why do these change? What causes these changes to happen? Why do you think that these change? How do you think these changes impact the code? Well, how do you think the changes in the code cause these changes? Now, while you're doing the experiment, I want you to think. So who still doesn't have it work? Bowen, have you managed to figure out how it works? Oh, okay. I don't know if I'm allowed to share my screen with you. Are you comfortable with sharing your screen, Bowen? So that I may be able to figure out what's happening. Okay. Well, could you describe your problem? Like, does it just the Bowen? Does it just not move at all? Does it freeze in place? So okay, so you've initialized the program. Let's try to do this one step at a time. Have you initialized the program? Top right corner, the corner right next to reset field. Then have you initialized the program? After you've initialized the program, yes, as pointed out by you, you have to start the program. Remember, you have to both initialize the program and start the program. Also, be sure your code on the left side should be pretty similar to my code that I show on the screen. Okay. Well, but okay, great. So so good. So again, just experiment with the front left and front right power and the front left and the sleep functions. Do be sure to experiment with them. I'll give you plenty of time. I understand you're a bit behind. Um, well, now that you've experimented a bit, I'll go and be showing what I'll be showing a demonstration of it. So I want you to I'm just going to do the demonstration now. So this is what you should have seen. So let me reinitialize the program. So this is without any changes. As you can see, it pushes the blue umbrella shaped object onto the white line. If you have the power, as many of you have noticed, the robot becomes half as powerful. It moves with half the amount of power it does. So good observation there. You did. Now afterward, let's see what happens if you change the sleeping value. So with the robot sleeps, if you increase the value from about 2,000 to let's just say 5,000, initialize the program and then start the program. As you can see, the program runs for much longer than it does if it's say 1,000. Now, I'll explain this all in more detail later in the PowerPoint, but this is what you should have noticed. As you can see, 1,000 only goes a pretty short amount of distance, and in 5,000 it works quite long. And of course, this power here, 0.5 and 0.5 reduces the power. Basically makes the motor slower. So, vroom. So here's the movement. So this is the command you've been messing with. This is the movement command. You can only start and stop the motors. You can't tell a motor to move a certain distance in a movement command. We will cover this later in more advanced code in the future, but for now, don't be concerned with that. So for a motor to move, you must tell it to start moving, wait for a certain amount of time, and then tell it to stop. This makes sense electrically, as you are basically sending an electrical current through the motor, causing it to turn. And then afterwards, you are just simply stop sending an electrical current, causing it to no longer move. This is the explanation for why you must wait, because it needs to spin a bit to function, then it stops. So in the virtual robot simulator, each robot by default just has 2 motors that will control 2 wheels. The left motor controls the left 2 wheels, and the right motor contains the right 2 wheels. Although in reality, though, you will generally have 1 motor per wheel. So you'll be dealing in FTC typically with 4 motors for the drivetrain. So to make our motor move, we must turn on the left and right motors, wait, and then turn them off. So here are the 3 parts of the motor command, motor movement. First of all, the front left set power, the front right set power. These set the powers to the motors that cause them to move. Power values range from 0 to 1, which changes the speed the motor moves at. So then afterwards, you then sleep, which is in milliseconds, as you have noted. So 1,000 milliseconds is equivalent to 1 second. So basically, sleep 1,000 is just 1 second, basically. During this time, the program doesn't do anything. It just doesn't do anything for a lot amount of time. Then after it sleeps, it then runs the program. You then set the power to 0. And what this setting the power to 0 does is that it just stops the motor, as it causes no power to be sent to the motors, causes them to stop. Does it make sense to everyone? Oh, anyways. So how can a robot turn? Going forward is great and all, but in the reality, though, it's much more useful if a robot can go more than one direction. Well, when both wheels move forward, the robot moves forward. When both wheels move backwards, the robot moves backwards. But here's the interesting part. When the left wheel moves backwards and the right wheel moves forwards, then, as you can see from this graph, the robot turns left. Now, notice it is turning left in place. It isn't shifting its direction when it's turning. And same goes for the opposite. If the left wheel moves forward while the right wheel moves backwards, then the robot turns right. So here is the code to show you what it would look like when you're programming this. So robot mode is active if the front left wheel are both set to the same power, positive power, then they move forward. This is seen by this part of the code. Now, if they're set to the same negative power, then they will turn backwards. And now for this one, since the front left wheel is powered on, is going forwards, and the right wheel is, since it's negative, is going backwards, this causes the robot to turn left. And of course, as you see any sleep commands, sleep 112,250 milliseconds is equivalent to 12.25 seconds. 1,000 seconds is 1 second. And 2,000 milliseconds is equivalent to 2 seconds. Now, I want you in the chat to put in what do you think the turning right command looks like. Now, you don't need to like write out the full command if you don't want to, but at least do something maybe like left, right, and then their respective powers. Very good. As many of you noticed, the front left power should be a negative number, and the front right should be a positive number of some sort. This should cause it to turn right. So here are compounding movements. To make your robot go forward and then turn or move another way, simply put the code for each type of movement in order you want them to be. Be sure to put a sleep statement for however long you want each movement to be in between the movements. In this example, code the robot to move forward at 0.5 power for 3 seconds, then turn right for at 0.5 power for 3 seconds. Now I'll let you go and be sure to I'll give you time to go and copy the code into your respective visuals virtual robot simulators, and so you can try this out yourselves. When you have managed to go and when you manage to copy it down and successfully run it, do be sure to leave a message in chat to let me know. And feel free to experiment with other compound movements, or with even more, or shorter, or with different power settings, or different sleep times. Feel free to experiment. So again, if you successfully manage to go on and copy down the code as shown into your own virtual robot simulators and manage to successfully run it, again, do be sure to communicate this to me in the chat. Oh, okay, great. Oh, great then. So again, the little GIF is the little GIF should show you what you should see though. Yes. But great then. Most people seem to be done. If you're not done, be sure to tell me so I can always go back to a previous slide. Here's a challenge, Han. You can go in. You will be taking what you've. Okay, wait. Okay, good. Bowen. Okay, you're not done. Okay. I'll let you go and finish copying it. If you want, I can. I'll go demonstrate how this code works in my own virtual robot simulator. So here, you set the power by half. You set this to 3000. You can then set to turn 500. And afterwards, you can initialize the program and start it. Are you done yet, Bowen? Oh, great then. Well, anyways, getting back to it. I'm sorry it was kind of interrupted, but again, here's a challenge. You can take what you've learned in this class so far, and you can apply it into a more well, you can challenge yourselves to test your to see how much you've learned. So here's a challenge. Make a square. Use the movement commands you've learned to have your robot move forward and then make a square. Again, consider adjusting your power or sleep times to have the robot move and turn the correct amount. So I'll give you time so that you can go and accomplish this challenge. Yes. What are the hardware map names for the shooters? Let's see what you're referring to. This is you will be learning about the intake and shooters later in the lessons. For now, we're not that advanced point yet, so don't concern yourself too much with that for now. You'll learn more about this in later lessons. When you manage to go and complete the challenge, do be sure to note down in the chat, but again, take your time. No need to rush now. if you manage to go and complete the challenge, do tell me in the chat so that I may be able to reveal the answer to you. Well, don't worry if your program doesn't go perfectly like the GIF. It just needs to roughly make a square shape. Don't worry, you don't need to like adjust the power to get it down to every single pixel. Don't worry about that. Well, don't worry about your code being a bit long now. You're only just started within the lecture, so no need to make it too fancy now. Again, if anyone else has completed the challenge, do be sure to tell me in the chat. Andrew, it is too hard. Well, what are you struggling on, Andrew? I can answer any questions you have if you do find this too hard. Where are you having trouble on? Is it moving forward, turning? The moving part. Okay. Oh. Wait. No, that's not to be it. Alrighty. So, let me go in and help demonstrate the moving part too. So maybe this can help you. So, as been stated, if you want the robot, why doesn't the robot listen to my code? Well, okay, a couple of things. First of all, if you change your code, be sure to reinitialize your program. If you initialize your program and then you have before you've changed the code, like see here, the front power is set to 0.5, so the robot should move quite slowly. Now that I've initialized it, even if I change the code, which is now I go to 1, and then I start the program, as you can see, the robot still continues to move quite slowly. Whereas if I reinitialize the program and then start the robot again, it moves at its regular fast speed. So again, if the robot doesn't listen to your code, then be sure you go and reinitialize the program and be sure to change your program before initializing it so that it will be changed. As you have trouble with the moving part, okay, and as been discussed in class. So as I'll redemonstrate my program. So if you set both motors to be at the same power to go forward, then they will move forward. If you set one motor to be, say, -1 and the other motor to be 1, and when you reinitialize it, is there a different amount of it turns different amounts of degrees each time? I tried it, it doesn't work. What's the biggest trouble? Again, if you have trouble, do be sure to communicate any problems you have with me. But as you can see, if you set it to -1, 1, it'll just spin around. It turns a different amount of degrees each time. So okay, let me go and address that problem. So the reason why a robot turns different degree amounts each time is it may be due to the fact that the robot's not turning 90 degrees. But for now, that's okay. If your robot isn't turning exactly 90 degrees, it takes a lot of trial and error to get down the angle. Let's see here. I tried it. It doesn't work. So let me go and give you an example of why it may turn different degrees each time. So for controllability, let me set the power to 0.5, half the power. And let's do some experiments here. So if you set it to 1,000, so if you set it to 1,000, as you can see here, the robot turns kind of a full 180. So if you go turn it 500 degrees, keep on saving the program in recent time. As you can see, it turns more of a 90 degrees angle. Now, if you want to turn exactly 90 degrees, then can you please paste your code here? Yes. Well, okay, I should probably just move on to the answer then. So here's the solution to the code. I'll just paste it in the box. And here's the answer to the code. And this is the solution. Again, it's okay if your code looks different, but there are many different ways to make a square on end. As long as you have your robot make a square shape like this, then you see it. So let me move on to the second challenge. For those who still have problems after seeing the solution, then do be sure to contact me and I can work with you more in depth on that. But for those who have already finished, let's move on. So here's the second challenge. Push the rings. So use what you've learned in the last challenge to push the orange rings to one side of the red squares and the other side of the field. If the rings disappear, hit the reset field until they return. Hint, you may need to consider turns where one wheel has power and the other wheel has no power, so that the robot turns with a different axis of rotation. Here's an example of that. As you can see, the front left wheel has 0 power, while the right wheel has 0.5 power. And then it's doing it for 0.7 seconds. Oh, great then. So again, like with the previous challenge, if you manage to complete it, do be sure to communicate with me that you have through the chat, obviously. If you have any troubles, I realized from last time, do be sure to just tell me if you have any problems and I can help you resolve them. Now, do keep in mind, this is the last challenge of this lesson, so keep that in mind. Nice. You're done, or do you have a problem? Or do you have a problem? All right. If you completed it, then that's also good for you then. Again, don't be afraid to share any problems you have with me. If you have any question, don't be afraid to ask. You don't have to struggle in silence. And again, if you feel ashamed or sharing in the general group chat, you can just privately message me to the chat, and you can also reach that way. Just direct message me. And again, if you manage to finish the code, then you share in the chat. Oh. Oh, let's take a look. See here. It'll just work. Well, some of you are convenient. Well, let's take a look at your code now. Oh, all right. So let's initialize the program and let's see here. Unfortunately, you haven't actually managed to push the ring from one side of the field to the other side of the field. It's a good start, but perhaps not. But it doesn't actually achieve the challenge. But it's a good start to it, though. I suppose it could be. I suppose the game setting could be different per person, but the basic thing though is that you should be able to move the ring, one of the orange rings, from again one side of the field to the other side of the field. I suppose if you've just managed to, push the rings, it's still quite a good accomplishment. If you haven't actually, though, on your side of the thing, because again, maybe technical errors or just differences within virtual robot simulators. If you if you are pushing the ring from the, or if you are pushing the one of the rings into the orange squares, then yeah, you've completed it. If that's not what it's like on your computer, then unfortunately, um, I won't quite manage to achieve it. So again, if you've managed to go and complete the lesson, then do be sure to tell me the challenge. Ah, great. Well, some people are finishing up. Again, take your time. No need, no need to rush now. I can, no need to rush. Hmm. If you do manage to complete it, again, just do be sure to tell me. And if you have any problems, once again, don't be afraid to communicate them. Oh dear. Well, since this meeting is coming to a close, since I realize it's 12 p.m. right now, if you're in a bit of a rush, which understandably you might be, here's the answers to the code. I'll put it in the chat. Oh, excuse me. That's a bit ahead of time. Alrighty, I'll put them in the chat. Again, if you haven't managed to complete it yet, then I encourage you to not just look at the answers and still continue to try to push the rings into one of the red boxes. But for those who are done, I'll just copy and paste into the chat. And yeah, here's an example answer. Again, there are many ways to go and achieve the goal of pushing one of the rings. So it's fine if your code looks different. And this is just an example of one that works. And as long as you put it in any one of the red squares, it doesn't have to be the bottom right square. It works. So halfway. Keep on struggling. I understand that programming is often very, very frustrating in reality, since you have to change a lot of very small numbers and fiddle around with the variables a lot before you can get the intended result. So I hope this lends some insight into computer science in general. Also debugging. There's a lot of bugs normally in programming. So many bugs. Oh gosh. Again, I encourage you to not look at the answer. If you have any questions, do be sure to feel free to ask. Well, Good job. Let's see another way. And Jane, is it okay if Charles, yes. Is it okay if I use your example to show another way of how you could have possibly solved it? Oh, great. Well, again, just to demonstrate that there is indeed more than one solution to this problem, and that every solution is equally valid. Here is Charles' code. Here's Charles's code. Some indentation problems. Program, initialize program, and yes. Yes, and as you see it, this is another way you could possibly solve the problem. So again, there's more than one solution, so don't be discouraged if your solution looks different from the one that I sent out in the chat, or if what you're currently working on looks different. Again, there are more than one solutions, and they all work equally as well. So just to be informing of those who are still staying behind, in order to not waste your time, there's after the solution, there's not actually another slide. So you can start leaving now if you have managed to complete the challenge. So feel free to leave if you want. But for those who are still working on it, again, I'll stay behind to help you. For those who are remaining, I'll let you slowly work through it. If you do run into any programming challenges or anything of the sort, again, you can always ask me. Yes, you're welcome. No. So again, for those who are remaining, if you have any problems, feel free to share. And I can help you answer any problems you may have. Oh. Well, no worries. For those who are remaining, would you like me to help you with your codes, or are you doing okay and you're just progressing along? As of being has gone 15 minutes over schedule. Would you all be okay if I ended the meeting right now, or would you prefer if I kept continuing on for longer? Don't worry if you have to leave. Don't worry. This recording will be posted to YouTube, so if you do want to go and take a look at it again, you can go and rewatch on YouTube. Don't worry if you have to leave. So with the rest of you who are currently remaining, would you be okay if I ended the meeting? Oh, yes. I've already shown the answer, but and I posted it in the chat already, but sure, I can repost it again. So this is the answer page. So this meeting has continued on for a bit too long. Do be sure to record the answer down. Again, you can always take a look at the answers in the recording of this meeting. But if there's no major objections, I'll just end the meeting right now. Is that okay with everyone? Well, great then. Yep. Again, if you do want to relook at these answers, you can just go and take a look at them in the recording. Well, thank you for being with this meeting. Thank you for joining this meeting. I hope you can return to join the further lessons, and have a good rest of your day. Let's see here. Stop sharing.